Welcome back to Mastering C++20 Features. In the last lecture, we looked at compound requirements and understood how to leverage it to impose the requirement on the return type of an expression and how to ensure that certain expressions don't throw by specifying no except as a constraint on the interface of a given type. In this lecture, we will look at the fourth type of requires expression, that is, the type requirements. The type requirements can be used to check if a certain type provides a nested type. Consider the function example add to collection from the first concepts lecture. We can check for the standard library containers that they provide a nested type called value type and specify the requirement that for such containers the nested type matches the type of the value being added to the container by using a type requirement. With this demonstration, I would also like to complete adding constraints for the template parameters of the function add to collection that I promised in the beginning. Let's see this in the code. Here I have the same add to collection method with the following requirement. Collection can be any container that provides a pushback method. The type of the collection in the container must have the same type as that of the value that is intended to be added to it, and the value is a copyable object. If you go through the CPP reference page on STL container, let me open it. You will see that they have a nested type member called value type. Here I have the CPP reference page for std vector, and they have a member function for the type which is called value type, which refers to the same template parameter t that is passed to the vector and refers to the type of collection that they should hold. And same goes for std list. Std list also has a member type which is called value type. You can check this on other STL containers like std array, std forward list, std queue, and so on, and verify that they have the nested member type called value type. We can use this fact and specify the requirement on our type parameter collection that is being used with the generic add to collection function, which will also demonstrate how to use the type requirements. So let's go ahead and do this for our add to collection method. I'll again use a named concept called addable to collection. So let me type this out here. And now in the body of the requires clause, I can specify the type requirement that the type collection has a nested type called value type. So this can be done by starting the requirement with the keyword type name, and then collection, scope resolution, value, type, and semicolon. Note this is not a member of the collection, but simply a type alias that refers to the type that the collection can have. For example, in the case of std vector int, which is here, the type of the collection or the container is std vector, and the value type held by the container is int, which makes up the collection of the container within std vector. Alright, this is the type requirement that we specified. Now, if someone intends to use this container on a custom handcrafted container class, this constraint will then ensure that the new container class will, to some degree, have similar interface compared to STL classes. While we are here, I'd quickly like to add the remaining constraint in the concept. First, I can add the constraint that the container specifies a pushback method. You all know this now from the previous lecture. I can do this by simply typing container pushback and value. Next, I will add the requirement that the template parameter t has the same type as the nested type within the container, which is our value type. For this, I will use the standard concept std same as. Let me first type this out as a nested requirement, std same as collection value type. So this is the type within the container, or the type of the objects that is within the container, and it should match the type of the value that we want to push back. Note that we cannot simply use the collection scope resolution operator value type because compiler will think value type is a member within the collection. To correctly tell the compiler that value type is a type alias, we need to use the keyword type name before collection scope resolution value type, like this. Now we have correctly specified the requirement on the value of the collection that it should be same as that of the type that we want to push back, that is taken by the method add to collection. And finally, I can add the requirement that the type parameter can be copied by using the standard concept std copyable. This constrains the type parameter t that it should provide a copy constructor and a copy assignment operator, and hence the value should be copyable. Let's see the CPP reference page for this once. And here it is. This is the standard concept std copyable, and the copyable specifies that the type t is movable object, and hence it can also be copied by construction and by copy assignment. So this is what we are going to use. Let me switch back to the editor and type this out here as a nested requirement again. Requires std copyable t. And let's try to compile the code. And everything compile and work. So now we can use this requirement addable to collection on our add to collection function. I will simply copy it and paste it here and type the type parameters, collection and t. And firstly, note that we have a std vector of int, and we are trying to push back a float value to the int via add to collection method. If I try to compile the code here, oops, there's a compilation error. What happened? I forgot to add the requires keyword here. I've done this so many times, but I still forgot to add the requires keyword. Alright, now we see the compilation error when we try to call the add to collection method with a vector of int and try to add a float value to it. We get the error that the type of the collection does not match the type that we are trying to push back into the collection. Let me comment this out. Similarly, if I try to add a non-copyable object, I will get another compilation error, namely that the type t that we want to push, which is our std thread, is not copyable. And add to collection requires, or the constraint on add to collection requires that the second type should be a copyable type. So that's all I wanted to show you in this lecture. In the next lecture, we will look at how to specify constraint using a type requirement on a template specialization of a given type. So stay tuned and enjoy learning modern C++. Thank you.